In the previous lecture of signals and systems, we saw the time shifting operation of the continuous time signal. As I have already mentioned, the shifting operation of the continuous time signal is of two types, time shifting and amplitude shifting. So in this lecture, we will understand the amplitude shifting operation of the continuous time signal. We know that a continuous time signal or CTS is a function of independent variable time t, and it is defined for all the values of this independent variable t. Continuous time signal can be represented by xt, where x is the dependent variable and t is the independent variable. Amplitude shifting operation is a signal processing operation that shifts the signal either upwards or downwards in amplitude by real positive constant k. So mathematically it can be shown as yt is equal to xt plus k, where k cannot be equal to 0. Let's consider a system which does the shifting. Now input to the system is the continuous time signal xt, and output of the system will be yt, which is the amplitude shifted version of the continuous time signal xt, or yt can be written as x of t plus k, where k cannot be equal to 0. Based on this value of k, amplitude shifting operations can be of two types, upward shifting operation and downward shifting operation. Let's see the condition for upward shifting operation of the continuous time signal. Again, the amplitude shifted version of the continuous time signal xt can be expressed as yt is equal to x of t plus k, where k cannot be equal to 0. Now, the upward shifting of continuous time signal takes place when this k is greater than 0. If this condition is true, then k will have the value range from 0 to infinity, or possible values of k will always be positive and greater than 0. Mathematically, it can be shown as yt is equal to x of t plus k, where k lies between 0 and infinity. This amplitude shifting operation only changes signal in the amplitude axis. No changes takes place of the signal in the time axis. Now let's see the condition for the downward shifting of the continuous time signal. Again, amplitude shifted version of the continuous time signal xt can be expressed as yt is equal to xt plus k, where k cannot be equal to 0. Downward shifting of the continuous time signal takes place when this k is less than 0. If this condition is true, then k will have the value range from minus infinity to 0, or possible values of k will always be negative and less than 0. So mathematically, it can be shown as yt is equal to x of t plus k, where k lies between minus infinity and 0. When k is equal to 0, no change takes place in the signal. Now let's see an example for the upward shifting operation of the continuous time signal. The condition for the upward shifting operation of the signal xt was yt is equal to xt plus k, where k lies between 0 and infinity. Let's say k is equal to 2. So we have to plot the signal yt where yt is equal to xt plus 2. Now we will make a table for observing the different values of the signal xt at different time instants. On the time t is greater than or equal to minus 1 and less than 0, then value of the signal xt is equal to 1. On the time t is greater than or equal to 0 and less than 2, then the value of the signal xt is equal to 2. On the time t is equal to 3, then the value of the signal xt is equal to 0. Now we have to calculate yt, which is equal to xt plus 2. As yt is equal to xt plus 2, this is the upward shifting operation. Here we have to shift the continuous time signal xt in upward direction by 2, or we will shift the signal xt upwards by value of 2 in the amplitude axis. To shift the signal upward in the amplitude axis by value of 2, we need to add 2 with each value in the amplitude axis. This signal has 3 different values for 3 different time interval. Value of the signal xt for the time interval t greater than or equal to minus 1 less than 0 is 1. So if we add 2 with the every value of this signal from this time interval of t greater than or equal to minus 1 less than 0, then for this time interval the value of the signal or yt is equal to 1 plus 2, which is equal to 3. Again, the value of the signal xt for the time interval t greater than or equal to 0 and less than 2 is equal to 2. So if we add 2 with every value of the signal from the time interval t greater than or equal to 0 and less than 2, then for this time interval the value of the signal yt will become 2 plus 2, which is equal to 4. And on the time t is equal to 3, the value of the signal xt is equal to 0. And if we add 2 with the signal xt, then value of the signal yt will become 0 plus 2, which is equal to 2. So this is the upward shifted version of the signal xt, where xt is shifted upward by a value of 2. If we compare the two waveforms, then we can see that amplitude axis of the signal yt is shifted upwards compared to the signal xt, or upward shifting operation of the signal xt takes place. If we look at the two waveforms, then we can see that for the signal xt, time axis exists from minus 1 to 3, and for the signal yt, which is xt plus 2, time axis also available from minus 1 to 3, so no changes takes place in the time axis. So we can say that in order to obtain amplitude shifted signal yt, we have added 2 with the amplitude axis of the signal xt, and the time axis of the signal xt remains the same. So for upward shifting of the continuous time signal, we just need to add k in the amplitude axis of the signal for every instant of time, and no changes should take place in the time axis of the signal. Let's see the downward shifting operation of the continuous time signal. Condition for the downward shifting operation of the signal xt is yt is equal to xt plus k, where k lies between minus infinity to 0. Let's take an example and understand the downward shifting operation of the continuous time signal. Let's say k is equal to minus 2. So we have to plot the signal yt is equal to xt minus 2. Now we will make a table for observing the different values of the signal xt at different time instants t. Let's take the signal xt. For this signal, when the time t is greater than or equal to minus 1 less than 0, the value of the signal xt is equal to 1, and when the time greater than or equal to 0 and less than 2, the value of the signal xt is equal to 2, and when the time t is equal to 3, then the value of the signal xt is equal to 0. Now we have to calculate yt, which is equal to xt minus 2, and as yt is equal to xt minus 2, this is a downward shifting operation, and here we have to downward shift the signal xt by 2. Or we simply shift the signal xt. To shift a signal downwards by 2 units, we need to subtract 2 from each value in the amplitude axis, and the signal xt has 3 values for 3 different time interval. Here value of the signal xt for the time interval t greater than or equal to minus 1 less than 0 is equal to 1. So if we subtract 2 from every value of this signal for this time interval, then the value of the signal yt for this time interval will become 1 minus 2, which is equal to minus 1. Again, value of the signal xt for the time interval t greater than or equal to 0 and less than 2 is equal to 2. If we subtract 2 from every value of the signal for this time interval, then the value of the signal yt will become 2 minus 2, which is equal to 0. And finally, on the time t is equal to 3, the value of the signal xt is equal to 0. And if we subtract 2 from the signal, then the value of the signal yt will become 0 minus 2, which is equal to minus 2. So this is the downward shifted version of the signal xt, where xt is shifted downwards by a value of 2. If we compare the two waveforms, then we can see that amplitude axis of the signal yt is shifted downwards compared to the signal xt, or downward shifting operation of the signal xt takes place. If we take a look at the two waveforms, then we can see that for the signal xt, the time axis exists from minus 1 to 3, and for the signal yt, which is equal to xt plus 2, the time axis is available from minus 1 to 3. So no change in the time axis. We have subtracted 2 from the amplitude axis of the signal xt, and the time axis of the signal xt remains unchanged. So for the downward shifting of this continuous time signal, we just need to subtract k in the amplitude axis of the signal for every time instant, and no changes in the time axis of the signal should take place. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.